Welcome. In this video, we're gonna look at the solution of a logistic differential equation. We're gonna look at the general solution to a logistic differential equation. So before we go on, let me do two things. First, I'm gonna give you the equation that we're gonna solve the differential equation. So dy dt is equal to ky 1 minus y over L. So this is 1. 2, we're going to do partial fraction decomposition. On the following term, because we're going to use that to solve the integral. So we're going to do 1 over y 1 minus y over L. So we're going to do a partial fraction decomposition of this term. So this would be equal to a over y plus b over 1 minus y over L. Okay, so the way we solve this for a and b, which are the partial fraction constants, decomposition constants, is we multiply the left and the right side by this term. So we're left with 1 equal to a 1 minus y over L plus b y. Then we distribute this, so 1 equals a minus a y over L plus b y. Then we factor out a y, so that's equal to a plus and then we're gonna do b and then plus y, I'm sorry, a divided by L. So this should be, and then this will be minus b, and then the y here. But if we want to take the positive, that means that this has to be, so this is okay, b is okay, and then let's make this a negative, because when we distribute, that will give us this term, and then when we distribute y, that will give us this term, so this will be b minus a over L, and then this is equal to 1. Now we set the constant equal to the constant, so a, we find that a is equal to 1, and then b minus a over L. Notice there is no y term here to the first power, so what we do, we set it equal to 0. Then we solve for b. So b is equal to a over L. But notice we found that a is equal to 1, so this is equal to 1 over L. So we have another equation. Okay. So now this term becomes we plug in that 1, so 1 here, and then we put 1 over L here. That means that this thing is equal to 1 over Y plus 1 over L minus Y. So let's write it here to make space. This becomes 1 over Y plus 1 over L minus Y. We're gonna need this. Okay, so now we go back to the differential equation. So what we do is we isolate the Y on the left and the right and the T on the other side. So dy over 1 minus Y over L equals K dt. And then this is Y. Now we take the integral. Notice this here is this here. So to make this integral easier to solve, we did partial fraction decomposition. So that left side becomes 1 over Y dy plus 1 over 1 minus Y L dy equal to K dt. So here we can use the u substitution. So we let u equals Y and then du equals 1. So this integral becomes ln of Y plus, now here we let, so we forget about this one. We let u equal to 1 minus Y over L and I'm sorry, this one is already, so this one becomes, actually we already did the decomposition, this one becomes L minus 1. So would let u equal L minus Y and then du equal to minus 1. But I see a 1 here and we need a minus 1. So the way we do it is we let this integral look like this, minus 1 over u du equals, and then the right side is kt plus c. We only need one constant of integration. Okay. So right now we have ln of Y plus, so this one becomes minus, so it will be minus ln of u equals kt plus c. But notice that u is L minus 1, so we have ln of Y minus ln of L minus Y equals to kt plus c. Okay. So now let's combine these logarithm so into one. So the way we do it, so a minus becomes a this gets divided by this, so this becomes ln of y over L minus y equal to kt plus c. Notice we can drop the absolute value because the carrying capacity is bigger than your y value, your output of the model. Carrying capacity means that you have a limit. You have an upper limit on the model. That means that ln of y divided by L minus y equal to kt plus c. Now we take e on both sides. And this becomes y over L minus 1 equal to e kt plus c. Okay, so now let's get rid of this here. And let's rearrange this equation. Okay, so let's actually, before I wanna to make this thing easy. Let's go back here and let's do this. We have a minus here. What I wanna do is I wanna put this term on top, and I'll tell you why. Because it's gonna be easier. So the way we're gonna do it is we're gonna flip, so we're gonna make this positive, so it will be ln. So basically multiply the left side and the right side by a negative. This will be ln of L minus y minus ln of y equal to minus kt plus c. Notice the c doesn't change the sign because we don't need to, we're gonna get rid of it. You're gonna see how. Okay, so now we do then we'll have L minus y over y absolute value equal to minus kt plus c. The reason I did that is because now look, okay, this becomes an absolute value, so let's put it here. So ln of L minus y, remember the L is bigger than y, so this becomes we can get rid of this absolute value, so it will be ln over y equal to minus kt plus c. Okay, so now we take that e on both sides, and then we have L minus y over y equal to e minus kt plus c. See, this is easier because I can do like this. L over y minus y over y, which is just 1, equal to e minus kt. So basically I wanted to get rid of one of the y's, and the way I did it is by redoing the process and changing the sign of the equation. Okay, so this becomes e to the c, and then e to the minus kt multiplier. Okay, so L over y is equal to 1 plus e, and then what I'm gonna do is I'm gonna make this e to the c, just call it c, a big C, and that will be equal to a minus kt. So now here that we have this equation, we can solve our y, and we have y is equal to L over 1 plus c e to the minus kt. And then if we want to have like a function, this will be y of t equal to L over 1 plus c e to the minus kt. So this will be the solution to our logistic differential equation. And remember, in this model, this logistic model, we have limited capacity, and that is determined by L. And what that tells you is that this model prevents the model from growing indefinitely, because we're going to reach a limit. So these models may be more convenient for certain scenarios, like bacteria growth, where you have a limited growth or population growth, or anything that requires limited capacity. So thank you very much. That's all I wanted to teach you on this video. Don't forget to subscribe, please.